So we're going to start with the last section in this chapter, and this is section 4.4 on exponential equations. These are very important equations to be solved in financial applications. So in finance, you will see quite a bit of exponential equations. Now there are two kinds of exponential equations that we study. So the first type are those that can be written in this manner: a raised to the power u is equal to a raised to the power v. So it has the same base. Type 2 are equations that can be written as a raised to the power u is equal to k. So on the right hand side you have some constant k. Type 1 are quite easy to solve, and we'll see them in a second. Type 2 are slightly more involved, but they are far more important. So let's look at each one. So type 1. Now these are equations that are of this kind. So if the base is same, then all that you have to do is set u equals v. So you just take the exponent portion of both sides and put them equal to each other, and then you solve for whatever the variable is. So let's look at the very first one. So this says 3 raised to the power 2x is equal to 3 raised to the power negative x plus 9. Now clearly this is type 1 because on both sides you have exponents. Now these two things can only be equal if this is equal to the exponent on the other side. So that means you take u, which is 2x, so this is the u, and you set it equal to v, which is on the other side. So that means 2x is equal to negative x plus 9. Now you can add x on both sides. This is a simple linear equation and you know how to solve them. So that gives you 3x equals 9, and then divide by 3 to get x equals 3. It's that simple. Let's look at the next one. So this is 2 raised to the power x is 8 raised to the power x minus 10. Now it is type 1, but you would notice that the base does not look to be same. On one side it is 2, on the other side it's 8. So we have to have same base to be able to use this method. But if you notice, 8 is actually 2 cube, because 8 is 2 times 2 times 2. So if I go and substitute for that, I'm going to get 2 cube raised to the power x minus 10, which means 2 raised to the power 3 times x minus 10. Now for this I use this exponent property, a raised to the power n, and then if it is raised to the power m, all that you have to do is multiply the two exponents. So that's what I did. I took 3 and multiplied it with x minus 10. Okay, now look at this and this. Base is same, therefore the exponents must be same. So that means x, which I am picking from here, must be equal to this, 3 times x minus 10. So that means x is equal to 3x minus 30. Now you can subtract 3x on both sides. Now this is the kind of stuff you've done quite a bit. So you get negative 2x equals negative 30. That means x must be 15. So that is the answer. Now we move on to type 2 equations, the exponential equations that are of type 2. So these are the equations that must first be written as a raised to the power u equals k. Now the thing to notice is that the coefficient of the exponent term must be 1. Then after that, the step 2 is that you take ln, which means log of both sides, and then use the power property of logs. After that, you solve for the variable of interest, whether it is x or t or whatever. You will see it once we do an example. So let's do the simplest one. So I want to solve 3 raised to the power x equals 5. Now if you notice, this is exactly in the proper form. So the first step we have to take is take log of both sides. So I'm going to write ln of 3 raised to the power x equals ln of 5. So I took logs of both sides. Now the power property says, if you remember the power property, it says log of x raised to the power r is r times log of x. So in other words, r just comes in front, the exponent. So same idea here, x comes in front, so I have x times ln of 3 equals ln of 5. So now remember, ln of 3 is just a number and ln of 5 is just a number. So I can find x by dividing both sides by ln of 3. So I would have ln of 5 divided by ln of 3. Now these numbers can be found by simply using your calculator. So for example, if you were to use your calculator, you would get 1.6094 and ln of 3 would be 1.0986. So you divide these two numbers and you're gonna get 1.4649. So that means the value of x is 1.4649. So now let's continue to the next example. So now I want to solve 5 times e raised to the power 2x is equal to 35. But if you remember, the proper form requires that the coefficient of the exponent term should be 1. However, here you have 5. So let me write it down again. 5 e raised to the power 2x is equal to 35. This is what I have. Now we don't like this 5, so what I'm going to do is divide by 5 on both sides. So when I do that, I get e raised to the power 2x is equal to 7. Now this is the proper form. So step 2 then says take ln of both sides. So I'm going to take ln of e raised to the power 2x equals ln of 7. Remember, you have to take log of both sides. So please don't forget this side. Don't forget. A lot of students forget to take the log of the other side. Then step 3 is use the power property. Actually, it's part of step 2 only. So step 2 says now use the power property. So that means the exponent portion comes in front. So you get 2x times ln of e So this 2x comes in front, equals ln of 7. So that means x, so this is step 3. So now if I want x, I have to divide by 2 and I have to divide by ln of e on both sides. So that means x is equal to ln of 7 divided by 2 ln e. Now some of you may remember ln of e is actually equal to 1, because what is ln? Ln is log basis e. So ln of e means log of e to base e, which is obviously 1. You could use your calculator to check also, and you will get 1. So that means this is ln of 7 divided by 2. Now you could use your calculator, and if you do that, you're going to get 0.9729. So that's your answer. Now let's go to the next question. This time we have this exponential equation. So again, the first thing to notice is that you have this 2 in front as the coefficient. So we have to first get rid of 2. So let's start. 2, 4 raised to the power 2x minus 1 equals 7. So I have to divide by 2 first. So this 2 and this 2 cancels, and I'm left with 4 raised to the power 2x minus 1 is equal to 3.5. Now just as in the previous question, you're going to take the ln of both sides. So this is step 2. So you take ln of both sides. So you get ln of 4 raised to the power 2x minus 1 equals ln of 3.5. Now use the power property, and this exponent will come in front. So you would write 2x minus 1. Now remember, 2x minus 1 is one quantity, so you must have parentheses around it. So when 2x minus 1 comes in front, you get 2x minus 1 with parentheses around it times ln 4 equals ln 3.5. Now remember, ln 4 and ln 3.5, these are just numbers. They're strange looking numbers, but they're basically numbers. So now it's a simple equation, and we can solve for x. So one way to solve it is divide by ln 4 on both sides. So I could divide by ln of 4 on both sides. So if I do that, I'll be left with 2x minus 1 equals ln of 3.5 divided by ln of 4. Now if you do that, then using your calculator, you're going to get 0.9037. Now add 1 on both sides, so you get 2x is equal to 1.9037, and now divide by 2, and when you do that, you're going to get x equals 0.9518. So that's your answer. So let me quickly repeat. So we started with this question. The first thing you have to always make sure is the exponent is 1. So you divide by 2 on both sides. That leaves you with 4 raised to the power 2x minus 1 equals 3.5. Then take log of both sides. Then use the power property to bring the exponent in front. So you get 2x minus 1 in front. Now it's just a usual linear equation and you can solve for x. And we get this. Now we will continue with applications after this.